Today we are going to look at a DSI problem, longest zigzag path in a binary tree. First of all, let's see what a zigzag path means. Zigzag path, so here, let's look at this with an example. You are given the option to start from any node and you can go, let's say this is our node, you can start from any node and you can go to you can take a direction. For now, let's say I'm taking a direction right. Now when you reach the next node, you can only choose a direction that is opposite to the current one. So initially if you have taken right, that means you have to go left now. Now you have reached the other node. Now again the same applies, you have to take the opposite direction. So again you are going right, then left. So this is a zigzag path as per the question definition. Now we have started in this case from the node to the right direction. Let's see what happens when you're starting from the node and taking the direction left. So let's say this is a node, you are going left, then you have to, once you go left, that means you have to go in the opposite direction next. Right, you were coming from right, you have to go now left, left, again right, left. So this is a zigzag that is being formed. Now we can form this zigzag on this binary tree only. That's a binary tree that is given. So let's do this with the example. So this is the example, this is the starting node. Now what we can do, we can look at the option where we take the right. So we take right here, we reach a node. Now there are two options, so either you can go here or here, but initially because we have taken the direction of right, now you are limited to taking only left. Now you reach here, can you do anything? There is nowhere to go, so you got a path. So this is the path that you got. So this is one path. So let me just clean this up. So you got a single path right now. Now let's say you are starting from the second node. So once you are starting from the second node, and this time instead of taking this time you are taking right, you are going here, then you have to go left, then right, then left. No, this is not possible, this left is not there, only you can go still here. Why can't you go here? You cannot go here because previously you have taken a right, now you are not allowed to take a right, you have to go left, then only right, but there is no left, so this ends here. So let's write this path down, 1 2 3. So you can see that there are 4 nodes and the path size become 4 minus 1, which is 3. So we are counting edges as the answer of this question. So always number of edges would be number of nodes minus 1. In this case also there were 3 nodes. Here there are 3 nodes, but the path size is 3 minus 1, 2. So this is 2 paths. Now let's say just now we can check, are we limited? Like in this question it is mentioned that choose any node. We can choose any node and start from there and trying to get a zigzag path. So let's start from, let me clear this. Let's start from some random node, let's say here. Again we don't have a left option. Yeah, let's start from a node where we have a left option. So here let's start from here. I'm start going left. So if I go right, what is the option? If I go right, there is nothing remaining, so this is the only path possible. If I go left, then I can go right, then I am done here, so I cannot go left again. So now this is the path, this is the path that is coming up. So in this question it is asking us to find the longest zigzag path. So you can see here we are supposed to find the longest zigzag path in a binary tree. So at any point you can notice few things. First of all, we are traversing to let's say let's like break this into step by step. So for now consider only finding the finding a zigzag path from a given node. So we are not trying to find the longest one right now. Initially we are trying to just find the zigzag path from a node. So let's say you are, instead of finding the longest one, yeah, we would come to that. So first we are trying to find, let's say, any given node. You are at any given node, you just need to find the zigzag path possible from there. So let's say any given nodes. So what is the zigzag path possible? So this is one option. When you are going left, you can also go right from this one. So when you go left, initially take the direction left. This is the possible scenario. So this is for left one from this node. When you initially take the direction right, here it ends. This is the only possible scenario. So first of all, when a node is given, you need to find the path. You need to find the zigzag path. So let's write a function to find the zigzag path, the length of the zigzag path possible from a node. We are not looking possible from a given node. If you are given a node, you have to find the zigzag path from that node. So let's say one more example. Let's take one. Here what are the options? You can go right, left, right. This is one option, or you would just go left. So from every node you can go two separate ways, going in the direction of left and going in the direction of right. So once you are given a node, you have to find the zigzag path from that node. So the first function we are trying to write is just simple, straightforward, finding the zigzag path from a node. So let's start writing. Private, we have to return the node, zigzag path size also from that given node. It returns an int. Name of the function, we put it as path. What we need, tree, node, root. Without root we can't do anything. And what are the options? So as I mentioned, from a node we have two options of it. We can either go left or we can either go right. I am using a boolean to represent left and right here. I am using a variable called dir, direction, which if it is true means we can go left, if it is false means we are going right. So just adding that here, boolean dir. Now what the first thing we need to check, it's a tree, so we have to check obviously whether the root is null check, because we have to if root equal to because you would end up at leaf node and the child from the leaf node would be null, so you have to deal with the leaf node scenario like when you reach null. So we are returning when you reach like if the current node is null, that means you can return return 0 for this one. Now what are the cases? So our current node, we can say it is not null, so there is two possible option, two possible direction, left or right. So if the value of dir, let's say if dir means if dir is true, that means go left. We are exploring the left side. So currently we have a node that is not null, so one node is there, plus now we are exploring the left side of this root. So root dot left comma. Now which direction we need to go? Once we take a left, next time we have to take a right. So I am inverting the direction. So currently the direction was left, now not dir. So current direction is true, now we made it false. That means the next in iteration it would go to the right. So this is here. Now if dir, oh, no need to type again if else. The else scenario is when the direction is false. False means what? Go to the right. So we need to put a return here, return. So false means you have to go to the right, you have to go to the right again. Once you go right, in the next level you have to go to the left. That means false is made true here. We are inverting the direction again. So we wrote a simple function to give the size of path from a node. So this function only gives, given a node, whatever root node you give here, from that node it would get the uh, it would give, okay, just a second, yeah, from the from any node it would give the zigzag path size. Now in the question it is mentioned like choose any node in a binary tree. So you are given, so there can be zigzag path that can be starting from the root or any other, so middle point. So it can be starting from here, 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 or anywhere. So the largest, in this case you can say that the largest zigzag path is starting from the second node. So if we just if we were just trying to find the largest node at this node, you would end up, it would go here and terminate. That's it. So you would end up getting 2 as the largest node. So you are, let's say if you end up just looking at here also, you would end up in the, if you check only the left side, you end up with a size 1. So the largest zigzag can start from any node in this tree and end at any node. So currently we are finding the path for a particular node. So what we need to do is try to find the zigzag path from every node. So how can we do that? First of all, line, we have to traverse the tree. How can we traverse? We can just start with a simple DFS. Like there are 2 options, BFS or DFS. We can go with a DFS, depth first option. Void DFS. So what we need, tree node, again null check, if it is null then we are returning TURN. Now what we need to do, so we can go to the, in a plain DFS we can go to the leaf child nodes. So DFS, again we can go to, sorry I forgot to write root. So root dot left, we are going to the left child and exploring that side. We are going to the right side and exploring that side. But if before that, once we reach a node, we have to, so let's say you are at this node, you have 2 options. You have to explore the left path and left zigzag path and right zigzag path before going to its child nodes. So what I'm going to do here is int left path equal to, how do we get the size of the left path? Using the path function we have already created, path root. So we are going to explore the left path. Left means direction equal to true. So direction TRU true, we are giving true as the value for direction because true equal to go left. Now we need to have int right path equal to, again path root, you need to go right means the value for direction you have to give false equal to go right. Now from, let's say this node, you have the left path, you have the right path. So you need to know which is the biggest path here. So what you are doing is, once you have this, max path equal to integer dot max left path right path So we have calculated the left path, we have calculated the maximum path. Now this max path we calculated is just only at this node. What is the maximum zigzag path possible from this node only? There can be bigger zigzag path possible from other nodes in the tree. So we would be calling DFS node left, and we would be exploring the right side of this subtree and again doing this calculation, but we need to keep the maximum we have encountered till this point. So to do that, what we are having is we would have a global max variable equal to 0. Now what we need to do is, once at every node when we get the node level maximum zigzag, we would max equal to digit dot max path. So we would just have we would keep the maximum value we so far encountered in a global variable. Now what we need to do from the main function, so the only thing we need to do from the main function is, so this function is able to traverse the tree and calculate so we initially what we did, we wrote a function to calculate the path size, zigzag path possible from a node. We use that function in the traversal function. In the traversal algorithm, we use the path function to calculate the left path, right path, and found out which path was the maximum. And while we are traversing the tree, we do this for all the nodes, and the maximum path we have encountered in our journey, we would keep it in the global variable. Now from the main function, you need to start the code. We would need to do is dfs root, and after running this, the maximum path would be updated at the max variable return max -1. Why this -1? Because as I have mentioned before, so we are actually counting the number of nodes here. This is you can see that in this tree, this is the maximum path. So the number of nodes is 1, 2, 3, 4. You have 4 nodes, but the edge size is 1, 2, and 3 only. So the size of the path or number of edges is number of nodes -1. So you have to -1 from the number of nodes to get the path size. So all this till this time we were always calculating the number of nodes in the path. Now we need to simply we need to have the path size only. So once you -1 from the number of nodes, you get the path size. You would be returning that. So let's run the code, see what happens. Yeah, so this is giving us the answer. Now let's explore the time complexity and space complexity for the solution. So here from a TC perspective, what does this function do? This function calculates the path calculates the path from every node. So let's say you are at this given node, you have to calculate the path. It would go the left and right direction. We are using this function, so it would just go this, or it can traverse this one. So from a node it can traverse maybe in the worst case it can traverse the whole tree. So this function is taking a time complexity of n, and we are calling this function for every single node. So at this point we are calling the path function, and on this node we are calling the path function. So for every node n, we are calling the path function which takes which is of time complexity n. So it would be, in the worst case, the time complexity would be big of n square, because we are traversing the tree, and on every node we are trying to get the maximum zigzag path. So the function to calculate the zigzag path is of n time complexity, because it can end up traversing the whole tree. So we are calling that from every node. So it is time complexity is big of n square. Now coming to the space complexity. For space complexity, we are traversing the whole tree. We are not using any extra space other than just one or two variables. But as we are using recursion, it is using function called stack. So in the scenario of a tree, it can the size of the function called stack would be equal to the height of the tree. So in this case, it can be, let's say, at the node, let me clean this, node 1, it is the function call is happening to the node 2, then it is going down. So so there can be, like, from, let's say it starts from here, it is going down till this point. So the function call stack can have a maximum value of height of the tree. Now in a worst case, let's say in our tree is structured like this. This is one node, this is second node, this is third node, this is fourth node. So for this node, the left is, this is null only, this is also null, this is the left child is null in all cases. So what is the height of the tree? The height of the tree here, it is 1 2 3 4. Height of the tree is 4. What is the size of the tree? 1 2 3 4, again 4. So in a worst case, when a tree structure is, let's say, like this, it can have space complexity equal to the size of the tree. So in space complexity would be n. Now, is this the optimal solution for this problem? Can a better solution be possible? Yes, it is possible. So this is not this is, you can consider it as a brute force approach. We are going to every single node, and from that node we are trying to calculate the maximum path. But during the traversal itself, we are able to keep track of the length so far and calculate the maximum. So in that case, we won't be running the path function multiple times from each node. So that is a different approach. We would see that approach in the next video. Thank you.